The next market vertical is warehouses. Warehouses usually do Wi-Fi deployment for inventory control and data collection. These are the primary use cases of deploying a Wi-Fi in a warehouse. Whereas, so it is pretty much similar to what we do in the retail segment, right? Where we deploy a network or we try to deploy a network on 2.4 gigahertz because of the old RF scanners that they have, right? The devices that are usually used in a warehouse would be RF scanners and some other devices at the checkout counters. But usually, I would say RF scanners, most of them are old scanners, so they support 2.4 gigahertz spectrum. So do not deploy a network on only 5. So you can go with 2.4 plus 5, but do not go for only 5 because there might be some areas in the warehouse, let's say the IT room or any other room where you do also have some laptops, right? And you would want the laptops to be on 5. So if you have an SSID separately for scanners, then deploy it only on 2.4. But if you have an SSID for scanners plus laptops, then do it on 2.4 gigahertz plus 5 gigahertz. Okay, so you need to keep these things in mind. And also, just like the retail, coverage is the main thing to do, not capacity. Do not focus on capacity, focus on coverage, because these devices do not need a lot of bandwidth to work. Just make sure that these devices, these RF scanners who are scanning the products, are getting coverage, are getting signals throughout the vicinity of the warehouse, because they will also do roaming. They'll be scanning and they'll be moving around in the warehouse, so they'll be mobile. So you have to make sure that yes, the RF signal is throughout, and the overlap is enough for the devices to roam properly, right? So also you will see some differences from the retail store, whereas in a warehouse you will see metal racks. The sources of interference in a warehouse would be really dense metal racks. So you'll have high metal racks. Okay, sometimes in some areas you'll have metal racks up to 10 feet, but in the other areas that height of the metal rack could go to 30 or 40 feet, 35 to 40 feet. Okay, and obviously you cannot mount the AP omnidirectional AP at the height of 40 feet. If you do that, you may not get a good coverage on the ground. So choose for directional antennas. Okay, now there are special antennas that come for the warehouses. Whereas if you have a warehouse deployed, let's take an example like this, and you have these aisles. Okay, there are some special antennas that also come. If you mount the antenna right at the center at the top of the ceiling, which is at 40 feet, okay, they should be able to cover the area this way and also this way. So there are special antennas, direction antennas that come, and so they are used specifically for these aisles coverage. So you can look out for those. If you don't have the luxury to get those antennas, then I would say, yeah, use any direction antennas and mount it in a particular direction and cover the aisle in the other direction like this. So that is what you can do. Also, design the network for the worst possible scenario all the time, because in a warehouse you will see racks mostly filled or sometimes empty. So the difference of the coverage attenuation, or I would say the RF signal attenuation, will vary drastically. If the racks are completely full of products, then you will have high attenuation. The RF signal will get absorbed. If you have racks completely empty, then it is going to be drastically different. So design the network keeping the worst possible scenario in mind. Keep the worst scenario in mind. What I do is I do a survey expecting, or marking the attenuation and assuming the racks are absolutely full. That's the first survey I do, and design accordingly. Also, I do another survey for my knowledge, keeping everything as empty. Okay. Now I have now what I do, why I do that is because I'll be able to understand the difference between, or how much variation can there actually be. So I do the design based on two scenarios. One is completely vacant, the other is completely full. and but I place the APs according to the completely full scenario, because that's the worst case scenario. Okay, so always design on that. And even if the RF stock, even if the stock comes in and out of the warehouse, or goes in and out of the racks, the RF can still be adjusted if we have enough coverage. But if we have less coverage, then it's going to be a problem. So make sure you do that. This is extremely important. People forget about this in warehouse designs. I've seen quite a lot of customers, or quite a lot of people who do RF surveys. They actually forget to ask this question to the customer. If do you expect the racks to be full? Do you expect the racks to be empty? And they do not design the network based on the worst case scenario. They design the network based on they just mark the attenuation as the standard attenuation in the Ekahau tool or the air magnet tool, and they forget to make sure you cover everything with the worst possible attenuation. So do that. And I think it's important that you understand why you need to design on a worst case scenario. But yeah, that's how warehouses are slightly different than retail stores. But yeah, other points I would say, design on coverage, not on capacity. Design on 2.4 mostly. The RF scanners are mobile. These are high metal racks, okay, for high attenuation. So make sure you play around with the antenna properly. And yeah, that's it. So thank you guys. I'll come up with the next vertical in the next video. That would be manufacturing. So we'll discuss more on that in the next video. Thank you.